Hi, this is Maggie. In this video we're going to look at event loops, the loops that drive most graphical user interface software. When you're using your computer, game console, or mobile device, you are running software or applications that respond to key presses, mouse movement, and button presses, touchscreen presses, and motion such as shaking or tilting. These activities, among others, are packaged into events by the operating system and placed on a queue. Your application can pull events off the queue and respond to the ones that are meaningful for your application. Event-driven software has a main event loop which pulls an event off the queue and handles it until the event is one that signals that the software should quit, such as the user clicking the application's close box or choosing quit from a menu. We will look at a very simple pygame program that is driven by an event loop. First, I'll run the program. You can see that it creates a pygame window. The program does absolutely nothing if I click in the window or type on the keyboard. When I click the close box, the program exits. Let's take a look at the code. At the top of the program, I annotate some variables. I then create a pygame window and set the title to instructions to click the close box to quit. Now, below that, I have a while loop. The loop header is while not user quit. Where user quit is a Boolean flag, I have initialized to false. I will set that flag to true when the user clicks the close box and the loop will exit. After the loop, I send pygame the quit message so it can release resources. Within the loop, I have another loop. This is a for loop that pulls all events off of the event queue that have happened since the last time we pulled events off the queue. For example, I might have moved the mouse and clicked it, and both of those events would be in the queue. This nested loop structure will make a little more sense when we look at a slightly more complicated program. Now let's take a quick peek at the pygame event documentation. And you can see these constants, quit, key down, key up, for example, are constants that I can use to test the kind of event I've just pulled off of the queue. Picture the event queue created by the operating system as having a list of these event objects representing actions the user has taken. The pygame.event.get command removes the events from the queue and returns them as a list. The for loop will pull each event off the list returned by pygame.event.get one at a time, and the for loop body will execute once for each event on the queue until we've gone through the entire queue. I can look at event.type and compare it to the constants in the pygame documentation to know whether it's a kind of event I want to deal with in my program. In our program here, we are dealing only with the quit event, and we are dealing with that by setting the user quit flag to true so the program will end. But there are other events. To illustrate that, I'm going to add a line inside the event loop. Print event dot underscore underscore dict underscore underscore. This is a part of the event that shows me more detailed information. We won't be using that right now, but it will illustrate all of the events that are being generated that we're ignoring. So if now I run the program, I'll move the mouse over into the window and you can see a lot of mouse motion events which show the position of the mouse, its position relative to the last position it was in, and the state of the mouse buttons. If I click different buttons, and move the wheel, you can see mouse up and mouse down events. And if I type on the keyboard, you can see key down and key up events. Handling events is a pretty cool part of GUI and game programming, so let's make sure we understand the basic event loop so we can get to more fun stuff. This structure will be your basic event loop structure, a while loop that executes until the user chooses to quit, and then within that, a loop that pulls all of the new events off the queue using a loop control variable called event. You can call that whatever you like, but event makes sense as a name, and handles the events the program is interested in. Let's add a little bit of event handling to this just to make the program more interesting. In the text there is an example that handles a mouse click by drawing a star in a random location on the screen. Instead of doing that, let's draw stars that fill the screen. Let's start though by just drawing one star if the user clicks. Once we understand how to process a click and draw in response to it, then we can get fancy about what we draw and where. So first I'm going to pause the video and annotate a variable for the star surface and load the star in. Okay, now that we have the star, we want to process a mouse button event by blitting the star to the screen, and then we will flip the screen. Now looking back at the list of pygame events, we have both mouse button up and mouse button down events. I'm going to process mouse button up because I feel that's a clear indication of a click. In our loop, we're going to use an if-elif structure because event types are mutually exclusive. If the event type is pygame.quit, for example, it isn't pygame.mousebuttonup, so once our event has matched a type, we don't want to keep checking. We have if event.type equals pygame.quit, and then we're going to add an elif to that. Elif event.type equals pygame.mousebuttonup. We'll handle that by blitting the star to our screen. We can blit at 100, 100, just to put it somewhere. Now, after the for loop, but within the while loop, we'll flip the display. That will show the star to the user. Let's run that and see how it works. And I click, and a star appears. Now I can keep clicking, and the star is just drawing over itself because I'm always blitting it to the coordinate 100, 100 on the screen. So to make it more interesting, let's have the stars fill the window, adding one star each time I click. What I have here is the start of a plan. My window is 480 by 480 pixels, and my stars are roughly 10 by 10 pixels. So if I draw a star every 20 pixels starting at 1010, I should be able to squeeze in 24 stars in each direction. If I draw them like this, one row at a time, then I will keep the y coordinate constant while adding 20 to my x coordinate until I reach 470 if I begin at 10. Once I reach that value, I should reset my x coordinate to 10 and add 20 to my y coordinate. Once my x and y coordinates reach 470, I should reset them both to 0 and start over. It's hard to imagine a person being quite that into the program that it would get to that point. An alternative is to just stop responding to the key press at that point or start drawing at an offset. Okay, let's program that. So I'll need some variables, x and y. And I want to start them at 10. I'm going to start right out with magic numbers and leave it as an exercise to you to improve this by using constants and the get width and get height methods to make this as general as possible so it will work with different sized windows and images. Okay, so when the user clicks, what do I do? Well, to start and draw that first row, I want to blit to x, y, and then increment x by 20. If I run the program, that will get us through the first row. Okay, so we have to catch that value of x that means it's time to wrap. So we'll write if x greater than size, well, we have that constant in there, but I think it's better to use screen.getWidth. Then we'll reset x back to 10, bringing us back to the left of the screen, and we'll add 20 to y. Let's run that. And that works great. Well, I'll leave it as an exercise to you to catch the last star in the bottom right and to clean this up. I think it's a sufficient introduction to the event loop for now. So to practice with this, have some fun. Write an event loop that responds in some way to mouse events. It takes a little practice to get this right, but if you work from this example and modify it, you can't go too far astray. Remember to flip the display within the outer loop after you've handled the events. And don't add any new loops to this. Handle everything within the loops that are here. Work with this structure. Once you've fixed this up and written a few programs of your own that handle events, you're ready to move on. Have fun.